Hello everyone. In this video lecture, we will discuss about pointers in C. We will be discussing about the definition of pointers, initialization, that is declaration of pointers, then pointers to array, and pointer arithmetic. The pointer is an unsigned integer variable which contains the address of another variable. You can have a pointer to any variable type, that is any valid variable types in the C language. The pointer is called as the unsigned integer variable. Why? Because the pointer variable is having the address of another variable. Yes. Okay. The address should be always a positive number. So as we have the house numbers, so no house numbers has negative number, minus 45, minus 50, like that we don't have. Similarly here also, whenever address comes in the picture, that is going to be unsigned integer. That is why a pointer is called as an unsigned integer variable which holds the address of another variable. Right. Here actually we have two operands which are playing with the pointers. The first one is the unary or monadic operator, that is ampersand symbol. This symbol gives the address of a variable. Okay, we will see the examples. And another operator, that is star, which is called as the indirection operator or dereference operator or evaluate address operator. This operator provides the contents of an object pointed by a pointer. That means the star is called as the data at address operator. The star will get us the data which is available in the given address. That is the meaning of this statement. Contents of an object pointed by a pointer. Look at this example. Here, the variable I is an integer variable. Okay, when we declare a variable, what is happening inside the memory, the specific memory location will be assigned. Okay, whenever we refer the variable I, which will physically go to this address and fetches the data. Okay, so I is the integer variable which is assigned with this address 0012 FE B4 something. Okay, and where the data phi is stored. So this is the simple integer variable. I is a simple integer variable which is assigned with this address. Whereas P is a pointer variable or pointer or pointer variable. Okay, the pointer variable we have seen is unsigned integer variable. Okay, this holds the address of another variable. So the pointer variable P holds the address of the integer variable I, that is this one 0012 FE D4 is stored in the pointer variable P. Of course, that pointer variable is assigned with some other address. That's a different story. But the pointer variable holds the address of the variable I in this example. You understand? So here you see P. P is the pointer. So in the pointer, what is available? The address is available. Ampersand I. So what is the use of ampersand we have seen? This will get us the address of the variable or address of the operand. So ampersand I will get us the address assigned for the variable I. This one. So P and ampersand I are one and the same. Following? Then variable I. I is equal to what? 5. Right. Now I want to get the value 5 without using the variable I. Rather, I would like to access the value with the help of the address. Then we can use the star operator. Star operator is what? Data at address operator or contents of an object pointed by a pointer. Star P. In the pointer variable P, the address is available. Star address. Star followed by address. Star followed by the pointer variable will get us what? The data available at the address of the pointer variable. So the star P will get us the value 5. Hope you are able to understand, right? So with this, let us move on further. Coming to the initialization of pointer or declaration of pointers. So this is a general syntax. Type star variable name. So here the variable name is nothing but the pointer variable, which is of the given type. So right here we have some other examples. Before that, we have to understand one thing. A pointer variable is always bound to a specific data type except void pointer. We have integer pointer, floating point pointer, character pointer, right? Then double pointer, then void pointer. So the point I would like to insist upon here is that the pointer variable and the variable whose address is going to be stored in this pointer variable should be of the same type. This means that the pointer and the variable must be of the same type. What is the meaning? The pointer variable should be of the type of the variable, okay, whose address is going to be assigned to this pointer. You will understand better when you look at these examples. So here we have some declarations. Int a is equal to 3, int star I. So here what is the meaning? Int a, we know. So a is declared as an integer variable. And also assignment is made here. Or we can do in a separate line also, int a, semicolon. Then the next line we can do a is equal to 3. That is also right. Whereas here int star ip. What is the meaning? IP is the pointer variable because star is there of type integer. And float star p. Here p is the pointer variable of type float. So what is the meaning? The pointer variable IP is of type integer. So that means what? This pointer IP will be able to point to the integer variable only. Similarly, the pointer variable p will be able to point to the floating point variable only. There should be no type mismatch. Right. That you can see in the following example. And character ch is equal to a. Right. Now p is equal to ampersand a. P is the pointer variable of type float. Ampersand a. But a is of type integer. So type mismatch is there. So we cannot assign the address of an integer variable to the floating point pointer, or vice versa. So the type mismatch should not be there. That is why it is invalid. And here IP is the pointer of type integer, which is assigned with ampersand ch. Ch is the type character. So we cannot assign the address of the character type variable to the pointer of other types. Here integer. So this is also invalid. Coming to the last example, IP is equal to ampersand a. So IP is the integer pointer, a is the integer variable. So there is no type mismatch. This is valid. So here the address of a will be assigned to the pointer variable IP. Okay. Whereas we have one more pointer called void pointer. That is what is called as general purpose pointer. The void pointer is able to address to any type of variable. That you can see in this example. Int a is equal to 3, void star p. So p is the pointer variable of type void. So you know, void is also one of the data types. It's belong with, right? Int star ip. Ip is the pointer of type integer. Character ch is equal to a. So p is equal to ampersand a. Here p is the pointer of type void. A is the variable of type int. But this is correct because p is the void pointer, or we can call it as general purpose pointer. Why? Because it is able to point to any type of variable or operand or data. That's why it is valid. And here IP is equal to star ch. As in the previous example, this is valid. And p is equal to ampersand ch. P is the void pointer and this is character variable, but void pointer is general purpose pointer, so it is valid. So got, hope you got the point. Okay. See here, int p means p is declared as integer variable. Int star p, p is a pointer to an integer. Similarly, character and other types we can use. So actually what is happening inside the memory when we declare the variables means, so here I have some 3 examples. Okay. So normally character type variable in C language occupies a single byte in the memory. Integer type 2 bytes, floating point 4 bytes, double 8 bytes, and so on. Right. So when we declare the variables in the program, what is actually happening inside the system is that it will allocate memory space for the particular variable. So depending upon the size of the data type, it will allocate the number of memory locations in the memory. If it is a character, then it occupies only 1 byte. So it will allocate a single memory address in the memory. You can see here, single byte is assigned. This full address is 27503. That is assigned for the variable a of type character. Then int number. So number is the variable of type integer. So the integer type variable occupies 2 bytes. You can see here 2 bytes are assigned. But what is told? What is the base address? So this address 27506 and 07. These 2 locations or memory addresses are assigned for the variable number. Okay. But when you assign the address of this variable number to the pointer variable, what will happen? The starting address or base address will be stored. Similarly, here you see floating point variable, float number. So it occupies 4 bytes. So the memory will provide you 4 memory locations. The system will provide you 4 memory locations. So here starting from 275, 75, 76, 77, 78. 4 memory locations are assigned for holding the floating point data for the variable number. So the starting address is 27575. Following. Let's see some of the examples. See here. The program, simple program, int I is equal to 5, int star pointer. Then pointer is assigned with the address of the integer variable. PTR is the pointer variable of type integer, which is assigned with the address of the variable I. That is address assigned for the variable I. So PTR is equal to ampersand I. You can recall now. So ampersand operator will get you the address of the variable. Okay. These 2 lines can be replaced with the single line also like this. Int star pointer, which is equal to ampersand I. Here also int I can be separately given and followed by I is equal to 5. Similarly, here also we can either give it in 2 lines or single line like this. Now I am printing the address of I. Address of I. The address of I is star p ampersand I. So the address, the output for this printf statement is address of I is something like this. Okay. And the address of I, the next printf statement also I am trying to print the same address in a different way. The address of I is pointer. So I am using the pointer variable directly. Here I am using the ampersand operator followed by the respective variable. Ampersand I will get you the same address which is assigned for I. Similarly, PTR will provide you directly the address because PTR is already assigned with the address of the variable. Are you able to understand? Right. Similarly, it is also possible to assign the address of a particular variable to different pointers. Okay, like this, int I is equal to 3, int star p star q star r. So p, q, r are the pointer variables of type integer, and I am assigning the address of the variable I for p, q as well as r. So that means what? Multiple pointers. Situation may come when we write a program or coding. Okay, but I would like to tell you that this is also possible. So multiple pointer is also possible. I am assigning the address of I to p pointer variable, and the same thing is assigned to another pointer variable, and r is equal to p or r is equal to q. So here the pointer variables, that is pointers p, q, r, all are pointing to the same memory address. Right, this is also possible. And here some of the methods by which we can declare the variable, and also we can print the value by using the variable, or we can print the value by using the pointer. See the first one, int star space p. This is also a correct version of declaring the pointer variable. Or we can do like this, int star p1, int star p2. So two are pointer variables. Or otherwise we can do the same thing in a single this one, int star p1 comma p2. So these are different ways here also. So instead of int character, here we see the simple example, int star pc comma c. So pc is a pointer variable and c is a simple variable which is assigned with, c is assigned with 5 and pc is assigned with the address of the variable c. Okay, printf %d star pc. Here we can use directly c. If you use c here, you can get the value 5. Now I am getting the value 5 without the application of the variable c. Rather, I am using what? The address assigned for that variable. So star pc. Now you can recall in the very first slide we have seen that in the beginning we have seen that star is what? Address at operator. Data at address operator. Data at address operator. Star will get you the data at the address. So data at address operator. So PC is the address. So the address of C would have been stored in PC. Star address will get you the data available in that address to us. Right. Then another this one, int variable var is equal to 5 printf. So I am printing the value of this variable. So I am getting 5 and I would like to print the address of this variable, so I am using ampersand variable, so it will provide the address assigned for this variable. Then another example, int star pc c is equal to 5. Okay, the star should come here. Okay, as seen here, and pc is equal to star c. The address of c is assigned to pc. C is equal to 1. I am storing. So previously c was stored with 5. Now I have replaced the value of 5 by 1, right? So what will happen? In the address, in the same address assigned for C, instead of 5, 1 would have been stored. Now printf %d c. So we will definitely get us 1. The output is going to be 1 for this printf statement. Then I am printing the value by using the pointer, as you have seen here. Star pc will again give us the value 1. Right. Another example, the same thing is written in a different way. There is only one change in the fourth statement, the fourth line. Instead of c is equal to 1, I am using star pc is equal to 1. So here I am directly using the variable to assign a different data, but here I am not using the variable, rather I am using the address of that variable. So I am directly accessing the address. So that is the power of a pointer. So we can directly access this is not available in other languages, I can say. So directly we can access the memory. So you see here star pc is equal to 1. Means what? This is equal to c is equal to 1. So I am directly storing the value 1 in the address assigned for the variable, right? And we have got the same. Fine. And here one more thing I would like to insist, that the size of different variable types, the size of different types of data will be different. That is, for character it is 1 byte, integer 2 bytes, floating point 4 byte, double 8 bytes, like that. But the pointer will be of the same size. So you may have pointer to different variables. You may have pointer to different data types. We may have a pointer for integer, pointer for character, pointer for float, etc. But all those pointers will be having the same size. There is another point we have to note down. See here, star p, float star q, double star r. Okay. the size of integer pointer is. We have already we have seen in the previous unit. We would have come across the size of operator. Size of operator will provide you the size of the variable or data type. The size of p. P is the integer type pointer. Size of p is 4. This may be 4 or 2 depending upon the machine. If it is 32-bit machine, it will be 4. If it is 16-bit machine, it will be 2. Following? 4 bytes, 32 bits. If it is 16-bit machine, it will be 2. Then size of floating point pointer q. Again it is 4. Size of double type pointer r. Again 4. Character. The size of character. So everything is 4. So the size of the pointer will be same depending upon the number of bits of the particular machine. 32-bit means 4, 16-bit means, that is another point you have to note down. Then coming to the another important point, pointer to an array. Okay. Actually, when we declare an array variable in the C program, array means what? Already you would have seen. Array means the set of homogeneous data. Array means a set of homogeneous data. Okay. So here int x of 4, that means what? X is the array variable of size 4. That means those indices will be 0, 1, 2, 3 like this. Okay. So x of 4 means x is declared as the array variable of size 4. Starts from x of 0, x of 1, x of 2 and x of 3. Okay. And here I am writing the program to print the address of different locations. Different locations. Printf ampersand, we know that it will provide us the address. Ampersand x of I is equal to %p. Okay. So we will get the print ampersand x of 0 is equal to %p. This corresponds to ampersand x of I. Ampersand x of I will get you the address of the particular element. Now I is equal to 0, so x of 0. So which will provide us the address of x of 0, which is nothing but what? The base address of the array. Simply x or address of x of 0 are one and the same. That we will see here. So this x array variable itself is a pointer. Here x itself is a pointer because x holds the starting address, the base address of the array. Okay. Now the loop continues. I becomes 1. So I will be varying from 0 to 3 because I less than 4. So for I is equal to 0, we have already got the print. When I becomes 1, the same thing, but the address is different. You see here, we know that integer type of data occupies 2 bytes. So the address of x of 0 is, that is something ends with 48. Right. Then address of x of 1, you have to add 2 bytes with that one. You have to add 2 bytes with the base address of the array. So in hexadecimal, 48 plus 2, 4a. Then for x of 2, 4c. X of 3, 4e like that. Right? And the loop is broken and the value of I becomes 4. Finally, we have a statement here, address of an array. Address of array x is x. Address of array x is the starting address, 1450734448. So the x itself is a pointer. So that is why it provides the address directly, the base address of the array. Right. Here actually, when we increment the pointer, what will happen? The address will be incremented by 2 bytes in the case of integer. If it is of type character, the address will be incremented by 1, 48, 49, 4a like that. If it is a floating point, 48 plus 4, 4c, 4c plus 4, 50, like that. Okay, because we have seen already. So character data occupies single memory location, integer, 2 memory locations, floating point, 4 memory locations, and so on. Here you see ampersand x of 0 is equivalent to x, because address of x of 0 is very well equivalent to x, the base address of the array. And similarly, x of 0 is equivalent to star x. X of 0 is nothing but data at this point, at this location, which is equivalent to star x, data at address operator. Similarly, ampersand x of 1 is equivalent to x plus 1, and x of 1 is equivalent to star of x plus 1, and so on. In general, we can say star x of I is equivalent to x plus I, and x of I is equivalent to star of x plus I. Okay. And coming to the pointer arithmetic, here actually we can do some other operations and we cannot do some other operations. So do's and do nots we can see here. So we can add or subtract a pointer with an integer. For example, I have a pointer variable and I can add with that pointer variable with an integer value. Okay. Similarly, I can subtract. So I can move the pointer here and forth. And subtracting or comparing two pointers within the array limits that points to the elements of an array. So we can subtract the pointer within the same array limits. Similarly, we can increment or decrement the pointers within the same array limits that points to the elements of an array. We can perform with the same array. We can perform the increment operation or decrement operation or subtraction operation or addition operation within the same array. That is allowed. And a pointer to an integer is incremented by 1, that we have seen in the last slide also. The address is incremented by 2, as 2 bytes are used for integer. Suppose if you use a floating point, it will be added with 4 bytes. So that only it will be pointing to the next data. Such scaling factors necessary for the pointer arithmetic are taken care of automatically by the compiler. For character it will increment by 1 address, for integer it will increment by 2 addresses, similarly for other data types. And do nots, we cannot add 2 pointers. Suppose assume that we have 2 pointer variables, we cannot add them both. Similarly, we cannot multiply a pointer with a number. Also, the division is also not possible. Right. So what is possible? Addition or subtraction with an integer value. A subtraction is allowed within the same array. Addition is allowed. And incrementing, decrementing operations are allowed. Operations which are not allowed are addition of 2 pointers, multiplication of a pointer with a number, dividing a pointer with a number. These are not possible. Okay. Simple example here. Int x of x equals 0, enter 5 numbers. We have the regular this one. Here, only thing I would like to insist here is that instead of using the conventional statement for getting the input using scanf, ampersand x of I, instead of this statement, I can use what? Scanf of percentage x plus I. So ampersand x of I can be replaced with x plus I, as you have seen in the previous slide. Both are equal. Similarly, conventionally we are using what? Sum is equal to, this is a shorthand operator. Sum plus is equal to x of I means sum is equal to sum plus x of I. This statement can be replaced with sum plus is equal to star of x plus I. So x of I can be replaced with star of x plus I. Okay. So we have entered 5 values and the sum of the values are, sum of the values is 30 for this example. Right. Then another simple example. Array size is 5 here. I am assigning the address of the data x of 2. This is x of 0, x of 1, x of 2, x of 3, x of 4. I am assigning the address of x of 2. That means what? I am assigning the address of the data 3. So PTR is equal, PTR is a pointer variable, PTR is assigned with address of x of 2. So the address of this operand or data is assigned to the pointer. So you see here, star pointer, the star pointer. So pointer is having the address of this. The star address data at this address is 3. 3 will be printed. So now, as we have seen already, we can increment the pointer within the array or decrement the pointer within the array. So this second statement is increment the, we are incrementing the pointer. Right. Star of PTR plus 1. So PTR is address of this one plus 1. Actually here 1. So this is of integer type. Basically say assume that the address of this one is say 1000, 1000. Then if you use PTR plus 1, what will happen? Since the type is integer, 2 will get added. So 1002. So 1000, 1002, 1004 like that. So the data at the address 1002 is 4. Similarly, PTR minus 1. Say this is 1000. Okay, the previous address. Star of PTR minus 1. So the data at the previous address of the pointer. Hope you understood and enjoyed the lecture. Okay, thank you very much for your patient listening.